in the function, and then you told that you want to extract 6 out of it, so I just function with the list and whatever you want to extract, so then they find within that list. If there's a 6, then extract it. If there's no, then just say no.
Okay.
So that's basically what I wrote.
I get it. I get it.
Because I didn't.
So instead of the exact example I gave you and say write the necessary.
You said write necessary code
to extract the 6 from that list.
Yeah.
So you wrote a function that makes like recursive calls every single time it runs into a list.
Yeah.
And what gives you the
No, so then
either returns a 6 or a false if it couldn't find it?
Yeah. So
Right.
just keep going until it's find a 6 to split that to 6. That's it.
Did anybody else read it that way? The very first question where I gave you this giant list with lists instead of lists and crazy stuff, and I said write the necessary code to extract the 6. Anybody write a function to do that, or did you just use cars and cutters to ultimately extract it?
Cars and cutters.
So V was the only one.
Where'd it go, V?
I didn't use.
I thought about it.
What'd you use?
It's gonna take longer.
I just didn't do it.
Because I thought like there's something fancy about it.
You did what?
You could definitely just run a function to get it. You've done stuff like that. I was thinking about it, but I didn't quite remember. So.
I was like, okay, if it's a number, and it's
Okay.
moving.
If this variable is the 6, then take the 6 out.
Yeah, I told him to email them.
Oh, and then you just kept whittling it down?
Yeah.
Okay. So you kind of wrote a function too.
You said write
As
necessary
long as you
code.
run,
I was just
as long as
thinking
you,
of
I mean, as long as she
fancy.
calls the function with the thing, then technically she wrote the code for it.
Yeah, you're right.
If she doesn't, then well, you didn't do anything at all, B.
So I'm guessing it's probably in his email.
Well, like if you that function if you put in a list, say you want to look for a 6, it split out for you 6. If you want to look for a 5, if that list had a 5, split out for you 5. Otherwise, it just split out none.
And we didn't find anything.
What it does.
But technically, we'd only find the first 6, but in that case, it wouldn't matter if it's extracting the 6. It doesn't matter if there's 1 6 or 26s. It's going to give you a 6.
Yeah.
Well, all right. I guess technically that does answer the question. I'm just surprised that you read that far into it. I gave you a pretty crazy input and say, like, here's a list that has lists and lists and lists and blah, 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 blah. Write the necessary code to extract the 6. Doesn't that just scream write cars and cutters?
No.
Yeah, pretty much. Wow.
It's
Or
not though.
ders?
Yeah.
So then like
Just
you
put it
just
in the three, though.
just hard code a whole bunch of cars and curves.
Yeah.
Like curder.
Yeah.
Except there was cars in there. There's,
It'd make more sense.
Or you could do
honestly, to try to find a good function for it.
Yeah, when you have that many does, you got to throw a in there.
Oh, that's true.
Otherwise, you're mispronouncing
like,
it. All right.
Ah.
So anyways, Littman, what was it you wanted to tell Austin? What was the question?
Oh, about your eyelash?
Yeah.
What takes you so long? I mean, so you get an eyelash behind. You take the contact out, right?
Yeah.
And then you have reusable contacts.
Yes.
Okay, so you squirt it with the liquid, right?
I mean, I have reusable, but I took a new one.
Okay, so you have dailies.
Yeah.
Okay, so you didn't even have to get the eyelash off the contact.
But I couldn't. It fell off the contact underneath my eyelid, and I couldn't get it out.
But it wouldn't have it eventually blinked out. You just needed to get because it fell.
Painful.
It's now away from your eyeball where you can now replace the contact.
Maybe, but it was painful. So.
You just squirt the fluid in your eye. And
Was it a cactus spike, Austin? Doesn't sound like it was a cactus spike. It punctured my brain stem. All right. So what are we rating for today? What's the next thing for our language? Didn't I tell you? You asked me what the homework assignment was going to be, right?
Yeah, it was definitions and block statements.
Okay, so that's what it's going to be over the weekend.
Yeah.
So we have to write something else today.
Yeah.
All right.
They assigned us to write the conditional, and then we got talking about lambda calculus and didn't actually write the conditional.
Okay, but so definitions and block statements is what I said for Monday. So we need to write the conditional still.
Right.
Yeah.
Okay. We need to write. Oh, I thought didn't we write question for last class?
No.
That was your homework that was due last class.
Yeah.
You went to a spiel on.
We talked about data representation for Boolean zeros versus ones. So we talked about what you sucked at for the question homework, but we didn't actually solve the question homework, right?
You said no homework today.
Well, right, no homework for today, but the question homework was the homework that was due last class.
Mm-hmm.
But now you have an impossible assignment for Monday.
Hype.
Hype.
Email Blaine. Blaine.
I've been doing this for the last 2 weeks. Same thing.
All right, so here, let me remind myself from the notes what was the last thing I yelled at you about.
Also, if you find the hackathons in spring.
Oh, I did get a request from Austin this morning for me to attend a hackathon with the Hackathon Club. So one thing you'll have to do is you'll have to identify a hackathon that allows non-students to do it. And as long as it's organized, I'll go. And maybe I'll do my own team and compete against you guys, or I could go around and float and help the different teams.
We can use an art guy.
You mean he's the art guy? Mr. Gonzalez does all my artwork. I'm sorry, Reverend Dr. Gonzalez. He recently filled out a website.
Have any weddings under his belt?
Yeah. Does it have a first ceremony lined up? I mean, whether it's a wedding or.
Well, he's had a wedding. He had his own wedding.
Performing one.
Did I tell you we're actually doing because he got married on a princess cruise, actually in the wedding chapel. I have pictures.
Mm-hmm.
And we're going on that same boat in March. And they're staying on the same floor as the wedding chapel, so we're going to do a reenactment.
Who's the lucky doll?
It was Aunt Jemima, is his wife.
I forgot.
Yeah, that was. Here's the thing: is that these are all like stories, but they're based in reality. There is actually another elf on the shelf that lives at her house whose name is Aunt Jemima. He didn't realize that Aunt wasn't a first name. Yeah, it was a mail order bride from Jamaica. I have pictures of the unboxing. this whole thing. The best man was Caesar. Caesar's a stuffed hammerhead shark who also lives at the house. His pet is Ollie, a stuffed honey badger. We have a lobster, Pinchy. Oh yeah, this is V's note she put on my cup yesterday. She refilled my cup. She says, "Extra Mountain Dew for extra fat people. Please do not touch." That doesn't seem very nice, does it?
No, it's
Especially to put that on the cup of the person who gives you homework assignments or who's going to be grading your exam today.
Extra hard stuff.
no.
Extra hard stuff.
No, it's an F-A with a star and a T, so it's not the fat.
I'm going to focus in on that F. Because I still haven't graded the exam yet.
So since it's like Cleany star on the A, it's technically just it could be.
It's like the cadre.
What is that?
All right. Remind me, why do we have constructors and predicates?
To make stuff convenient for us in the interpreter.
Yeah, so that when we have it in our interpreter doesn't get us confused with a zillion cars and catters and all this stuff. We could just say, is the dude I'm looking at one of these guys? So our actual interpreter looks like our grammar, right? Okay. So we talked last time about how we were going to represent Booleans in our language since we actually don't have various types. Our language doesn't support types yet. So since we don't support types, we don't have a type expression. We have a lambda calculus expression. We don't have a type expression at this point because we don't support different kinds of types. We just have this thing called a lit expression that says, my values are numbers. Done. Full stop, right? All right. So we had to decide, how do I represent the idea of of trues and falses in the context of I only know how to store numbers, or I only know how to work with numbers as well as only store numbers. Okay, so we decided maybe we would do a 0 for false and a non-zero for true. Originally, I think I'd flip those around, but I was corrected in my stupidity in class. We'll just call it a spelling error. I think that counts. So really, the mistake is on Blaine because you didn't correct my spelling error.
Oh, what's spelling error?
I think I had advertised it as true as a 1,
Oh.
and false is anything other than
So
1.
language, it can be whatever we want it to be.
Well, that's true. That is true.
Yeah, see, he's.
Star for the day, and it's your fault.
Can I get a sticker that says that?
All right. But in the end, we decided we would stay true to the C language, where C represents Booleans as, well, with a macro, but as integers, where true is a non-zero value and false is 0. Okay? Humans would usually say it's 0 or 1. That's kind of the digital mentality of it. But the actual implementation says false is always 0, true is something other than that. Okay? So that's how we're going to ask our questions, is with that dude. Okay, so where's my grammar? I'm going to move the grammar down to the bottom so I always have it. All right, so we're adding a question expression to our grammar. And a question expression is going to have a question is the first thing, just because that's what we're doing is we're asking a question. And we need 3 things. All right, we need a lambda calculus expression, another lambda calculus expression, and another lambda calculus expression. That's what our question is going to be. Now, if I'm going to flesh it out a little bit here, really what this is, it's going to be a question, and then it's going to be something that boils down to a 0 slash, I'm just going to throw 1 there because it's shorter than saying something other than 0. Okay, so the first thing will be any expression that ultimately boils down to a 0 or non-zero. Right, that's what that first guy is presumed to be, similar to our app expression, where we assume the first guy is going to be a lambda. The production of our grammar that is the lambda expression. Production of our lambda calculus expression that is the lambda expression. All right, so our first guy will be something that boils down to a 0 or 1. The second guy will be any lambda calculus expression. Realistically, we could probably say it would be anything other than just a lambda, because lambdas really aren't executable in and of themselves unless we assume, well, yeah, they're not executable in and of themselves. And then anything else, any other lambda expression. But really what we would say here is this is maybe the true expression, and this is the false expression. False eep?
It corrected your question.
Did it?
Yeah.
I wonder if it's like based off of like spelling error patterns. It's like figuring out like just how bad does Lippmann spell. What? Luke.
Is there a way to make an optional parameter, like take one?
You mean like optionally have a else? Because that's what really this is, right? The false is really, this is our else expression.
Sort of like if you were to pass it like, is this a let's say var expression, and you just wanted to check it for one. You just want to check one parameter instead of like comparing 2.
Well, yeah, I mean, this guy here, all we say is it has to boil down to a 0 or a non-zero. We don't care how you get there. This can be a crazy looking lambda calculus expression with app expressions, calling app expressions, with lambdas left and right and lits and vars, all this stuff that ultimately comes down to a single 0 or a non-zero. Go ahead.
For the quick, I'm not sure if this is what you were saying, but for the question is whatever it is, now it takes in 4 bits, I guess, or 3. Sorry, 3. Is there a way to make it optional so maybe I can like go into, but like the third one's an optional parameter?
That's what
argument?
Yeah. So, well, isn't that kind of what I asked initially? Like, you mean to have an optional else? That's what I said, right? That you would ask the question and you would only conditionally do this true expression. But like in Java, for example, we're allowed to say, if this is true, do this. Optionally, we can then have an else to do something else, but we don't have to do something else. That's really what you're asking, right?
I was more asking like when you have args in Java,
Yeah.
you can include args, you don't have to.
When would you ever ask a question where you intended to do nothing?
When you have a function that's being used multiple times, and usually it's going to be set to a certain value, but you have the option to change it in the constructor.
Well, yeah. So you would ask the question, if the value gets set to what you think you should do, then actually do something.
Right.
You can optionally say, I don't want to do something else. That's how Java would support. Java doesn't require you to throw an else in. But Java always requires you to have the expression associated with the question you're asking. You can't just optionally say, okay, well, I'm going to ask the question. There you go. What's your name? Don't care. Doesn't matter what you say, I'm not going to do anything about it. Make sense? Yeah. So the short answer is sure, we can do something like that, but it might not make sense for our language. If we're trying to mimic the way questions work in most programming languages, we might ask a question and say, hey, is it cold outside? If it is, maybe I just don't go outside. Okay? Or maybe I say, is it nice outside? If it's nice outside, I'm going to go outside. Otherwise, I don't know what I'm going to do. So I'm not going to have an otherwise. I'm not going to have the else. I'm just going to, I don't know. I'm not prepared to make that statement at this point, right? Okay? It depends. That was remember that from our get together? Oh, see, those of you who missed the get together missed this inside joke where Professor Locklear, I guess, in HCI, the answer is always it depends. So I just kept bringing that up over and over again. So yeah, this was the Ann Arbor people. Why didn't we have them digitally at our get together?
That'd be cool. Can we just get beans for all of them? Like them.
Yeah, no, that was short-sighted. We should have at least invited them. They may not have been able to do it, but we didn't. I apologize, Ann Arbor folks. We're gonna have to have a special extra 470 get together where the Ann Arbor folks are yeah, because really, I'll tell you what, out of all the Ann Arbor classes that we have, the Ann Arbor students in 470 are the most engaged.
Good.
It's been a challenge. Not all of them are engaged, but they're the highest percentage of them are engaged. So yeah, in any case, we'll have to do something and include them in some sort of party, get them up on the big screen with a Zoom meeting or something.
Order them a pizza.
Have Micah send us the address. Look, let's just tell us where you want it to go. Then order them 200 pizzas and get them stuck with the bill. It's like, what? Man, that would just be destructive on my faculty evaluations. Dude sent us $700 in pizzas and made us pay. Yeah, totally worth it. Cordially required to buy $700 in pizza. Okay, so what we're going to do here to keep this relatively simple at first is we're going to say initially that we will require an else. Okay, we're going to say, look, if this is true, do this stuff. Otherwise, do this stuff. We can always make the call whether or not there is an actual else. We can check for that if we want to have an optional else. But initially, you got to make the choice. Do this or do this based on this question. Cool? All right. So we're going to add this question expression to our grammar. So we're going to, did I already build a constructor for this dude?
Don't know if you did.
Let's put it right after var expressions, maybe. So we'll define question-exp to be a lambda, and this guy's going to take 3 pieces, right? So he'll take a. Now, what's our preference? Do we want our constructors to kind of dictate in terms of their names what our types of parameters are? Because we're really saying this is going to take a lambda calculus expression 1, a lambda calculus expression 2, a lambda calculus expression 3. So really we might say this is our Boolean expression, followed by our true expression, followed by our false expression. So we can call this maybe true LC expression, false LC expression, and bool LC expression. That's probably reasonable enough. That gives us a little bit of some insight into what kinds of values this constructor is expecting from us. All right. And then what are we going to do? We're going to create a list out of question and then all these dudes.
Yeah.
You say eep?
I said yeah.
You said eep. That's what's wrong with my computer. This is your fault. All right. Isn't that the spelling correction thing it keeps giving me? Eep. Had to keep up here, Blaine. No. V what?
She's judging you again.
Oh, I just assumed you had a question. We should officially encourage all of the folks in Ann Arbor to send V a question.
Like to answer about class.
You're going to block all of your classmates from Ann Arbor?
Shoot her in Slack at
V. How are you gonna
right
get
now.
their numbers?
What?
How are you gonna get their numbers?
Get the digits. All right. So let's make our predicate now. So define question-exp question mark. That dude, is that how we're formatting?
Yep.
All right. So this guy's going to be a lambda. That's going to take in an LC expression, and he's going to just return whether the car of it is, what. So EQV car LC expression is question with the quotey thing. All right, so just like that, Blaine.
It's bugging me a lot.
Zero for the day, Blaine.
Right after getting that star.
Right after getting that star.
It's happened while I was working out.
All right, you have one thing you're in charge of, the spelling errors, and you just let me down. Yep, terrible.
No,
Don't get me started, V.
I fixed it. I just stared out on the screen and it went right.
This front row is under direct attack today.
I used the force. Stared right at it.
All right, so I have my predicates and stuff like that for that dude now, right? Is that how we're doing our predicates? Did I do that guy?
Perfect.
Yeah, I mean, really, this isn't overly great because we probably should check to see if it's even carable first, but because of the way we're using it, this is all for human convenience. We know we're not going to ask this question until we're down into the portion of our language that is lists of things, right? We're past the symbol and past the number. Now we're dealing with lists of stuff. All right, so come down here. And here, I'll just put it in the same order as we tested it up there. So we're going to say, is this guy a question-exp on our expression? If that's the type thing it is, we want to now get the first part of it and execute that expression or apply that expression, right, in the current environment. So we're going to go ahead and we will create a let. Here, I'm going to kick it down here. So we're going to say we're going to have a let, and this let is going to have a we're going to say bool expression is going to boil down to Well, we'll just get the first part of it. So we're going to have this guy be the, we can do the, whatever, we'll just write it in here. So this is going to be the CADR of EXP, EXPR, like that. That's our bool expression. The car of the cooter, because we got to burn past the word question. All right. And then we're going to have our true expression is the car of the cooter, EXPR. And then our false expression is, we really could, if I think, didn't I say we're going to assume we will always have an else here? I think I said we're going to assume we have an else right now, but we really could ask the question here. We could ask the question if the thing's an empty list, then just boil down to the empty list. Actually, we would get it anyways, right? If I take the car of the cooter, I would be trying to take the car of nothingness. So I would have to do the ask if the CDDDR is the empty list, then we don't have an else. That's how we would optionally accomplish the else. Right now, let's keep it simple. We'll assume we have an else. So we have our false expression. This is the CADDDR, EXPR. So that's our mini environment we're creating. We have our three little pieces there, right? So now what we're going to do is we're going to ask a question. If you want to ask it? This is our implementation. The implementation of our interpreter. We are writing our interpreter in Scheme. This guy can't function unless we can ask questions in our implementation. We're not allowed to put an if in our language, in our syntax, in our made-up language, which we have to name here pretty soon. We have to give it a good name. Let's let the Ann Arbor people name it, since we let them out of the get-together.
So we're not doing a special 470 get-together?
No, we'll do that anyways, but this is like an initial peace offering, right? So Ann Arbor folks, post in the 470 channel a name for our programming language. And then we can figure out which one's the best and go with something else. All right. No, we'll let them choose the name for our language. But remember, just like we were talking about last time, when we implement our interpreter, we are using Scheme. We have available to us all of the Scheme constructs, right? But the language that we're implementing has limitations. All right. So when I ask the question here, I'm going to say if equal to 0, let's say, and then what? Apply expression. So I'm going to pass apply expression. What am I going to pass it? I'm going to pass it the bool expression along with my current environment. Go ahead.
Is there a reason why we aren't using apply program? Because it'll pass it the environment also.
Well, because what I have here is an expression.
Okay.
And what do we do with? I mean, you're definitely wrong.
Okay.
But what we've written up to this point is a little misleading because we do actually pass an initial expression to our program rather than passing it a program and then extracting the expression. Okay. Does that make sense? So really what in this case, in our world inside the interpreter, if we have an expression, how do we get the value out of it? We call apply expression. We just use our apply program as the way to kind of get the interpreter rolling with a starter environment. Okay. So that's the guy that initially injects the environment here. All right, so apply expression here, I have access to an expression and an environment. I've now ripped out a little piece of that expression called bool expression, and I'm going to go ahead and execute that in that current environment. So I'll call apply expression, bool expression, env. Compare the result of that to 0. If the result of that is 0, that means it's false. So what will I do? I'll boil down to apply expression, false expression, ENV. Otherwise, I'll call apply expression, true expression, ENV. And that's what questions are. So now I can come down here and I can write a little test expression. So I can say I want to create a question. Is this how I do it? Question-exp? And then we'll just say lit expression 0, which should give us a 5, right? So this should boil down to a 5 since this is false. My false expression is the 5.
Yes.
There's my 5. If I change this to something other than 0, now it's true, I should get the 7. All right, so there is our question. Make sense?
I did mine way.
You said you did yours way worse?
Yeah. Pretty much.
That's kind of why we go over it in class. So it's like
Like,
show you hopefully a cleaner,
yeah,
not always a cleaner way.
functionality.
Sometimes Blaine has a reasonably bad idea, and then Jack saves him. All right. So that is our question expression. Any questions about that? Questions about questions? All right. Now, what if we did want to have an optional piece here? What we could do is for our I'm lost. Where's my, oh, here's question. So for false expression here, we could really ask a question in here to get us our value. So we could say if null CADD or CDDDR expression, if that guy is null, then we will have our, I'm not done yet. Oh, thank you. If that guy is null, then what am I going to do? Maybe I boil down to, no else or something like that. Something to let us know. Nothing to do. Or do we just boil down to nothingness?
Empty list.
Empty list, you think? Reasonable enough. We can decide what it means to not do anything. Okay. Otherwise, we'll boil down to the CADDD of the expression. All right. So now what we allow ourselves to do, actually, I need to do something here. So instead of just apply expression, false expression, I need to ask the question if null false exp, then boil down to false exp. I know, I forgot to close it. Else boil down to apply expression on false exp. I have too many thingies. All right, so false expression. Let's see, is this guy closed there? That gives me a false expression. This ends my let right there. Then we have the body of the let right here. And then we end our question there. So now we can come down here and we'll still get the correct answer for this guy. So we're still looking at a 7. Then we can change this back to a 0 and we'll still get the 5. But now I can optionally remove my else and just say, if this is something, boil down to 7, otherwise boil down to nothing, we should get the empty list here. 3 arguments with, oh, my constructor takes 3 arguments. The constructor is upset that I did not pass it 3 arguments because my question guy expects me to give it 3 arguments. I wonder, can I create a... Will it let me do this? Yeah, I think it's going to be in conflict with the name.
Be like, hey, we got 2 definitions for the same thing.
Can we do like a listening appendix?
Because when you do that, it's just-
Well, it could.
We can do a listening appendix.
Yeah, this name was previously used and... But if you took a list in, then you're giving them the opportunity to possibly have a whole bunch of expressions in there.
So if you're taking a list instead of 3 distinct params, you could send in a 2 list instead of a 3 list.
Correct, you could, but then you could
But you
also
have to-
send in a 3 list or something like that.
Yeah.
So what we'd have to do here is we'd have to explicitly say that
Right.
we have an else that is the empty list. And by doing that up here, we don't need to do this. This guy will always be true. So false expression will always be CADDDR, because if we don't want to have a false, we would pass in the empty list as that expression. Nothing to do, it's just part of our syntax. But then we'll ask the question down here whether or not it was actually a something to do or not. So there's our empty list. All right, so what is next in our language? So we decided we were going to have a block expression, and a define expression. All right, so let's look at a block expression first. So we have a block exp. Now, what are we trying to accomplish with our block expression? So if we think about block expressions in, think about block expressions. What is this guy? A block expression in Java is something like an opening curly brace, exp, 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 dot, 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 exp, whatever, closing curly brace. And then we can Ninja. So that's what a block expression looks like in Java. Opening curly brace, and we say do all these guys in a row. Make sense? Okay. So this guy ultimately says block expression is a list of expressions that should be executed in order but each may have an impact on the environment used for the next. And that's going to go hand in hand with our define expression, right? In Java, we might say int a equals 5, and then say display a. Well, that display guy relied on your environment being a little bit bigger than it used to be. right? So if we take an example of this in our scheme thing, you know, we might say we want to define A to be 5. And then we might say lambda x A. And this would be an app expression, right? So I would pass it 7 or something like that for that guy. So this might be inputs for that. And if we just kind of, this might be a begin. Oh. We'll call it block rather. So here's our block expression, for example, where we're first going to define A equals 5. And what's that going to do? It's going to expand our environment to now have a variable in it called A that's equal to 5. Then the next expression is going to be this app expression that has a lambda as the first parameter. And then the second parameter is, we actually support multiple parameters in ours now, but we're only giving it 1 since this guy only is looking for a binding for 1. So this is going to bind 7 to x, but then the body of this lambda relies on a variable named A that we presumably would not have access to that variable A until after the environment had been updated there. Make sense? So if I just did this, let's say I had my environment that had nothing in it. So coming into this block expression, I had an empty environment. Can I execute that line in an empty environment? Yeah, that line expands an environment, right? Can I execute this line in an empty environment? It's going to crash. My empty environment will not have a binding for A in it. It'll have a binding for X that gets created in real time when we're processing this app expression, right? Because it creates a binding for X equals 7. But I will not have my binding for A unless I am executing this second line using the newly created environment that was the result of that first line. Make some sense? Remember, this is an environment passing interpreter, which means that we are always executing an expression within a current environment, within a given environment. And environments might change as we add new variables to our scope. Okay? So our block expression here, we have to go through and we have to execute them in order. We can't just apply expression with the current expression across that list. Because that means I'm executing every one of those expressions with the starting environment, not the potentially changing environment as we go from line to line to line to line. All right, so we'll execute this guy first, which will result in, let's say nothingness. So maybe the output of this guy will be a list. And maybe when we successfully define a variable, we get a true out of it, something like that. And then the next thing will be lambda x, what you see here, this guy. And it'll boil down to the value of A. So this true says that we were able to create a binding in our environment for this guy. So now what we say here is the output of this app expression would be the value of A, which is 5. So maybe that's our desired output for a block expression. The result of each line of our block, where a define has the result of true if it worked, false if it didn't, something like that. That makes sense? So the output is a list of, just like repeat, we had a list of the repetitions through it, right? This is going to be a list of the results of all of our expressions contained inside of the block statement, where each expression might have an impact on the environment. Go ahead.
And is it all right to keep it consistent? So maybe we have the symbol block in as the first part of our list for the output.
If you want. Did we do that for repeat?
Yeah.
So our output for repeat had repeat on the front of it?
Thought so.
That didn't sound right to me. Here's our repeat. So we we just caused imply expression.
Oh.
Yeah, we didn't put the word repeat on there.
Okay.
I mean, if that makes you happy, you can.
I'm thinking of the constructor. I'm sorry.
Oh yeah, constructor for it, we would.
Yeah,
I mean,
yeah,
we're gonna build. I mean, this is an example. This is a block expression with the word block at the beginning of it. Yeah. So yeah, that's all fair game. All right. So for your homework, we're adding a block expression, and we're adding a define expression.
So do we have to name it something
Okay, so then it's
Who?
other than define, because define.
Well, we're calling it a define expression.
Ooh.
so does that mean
But
so does it mean that we're using like a
actually, I agree with you for a different reason. We're gonna call this guy a remember expression.
So that we're separating those.
Yeah, remember, I teach programming from the idea of we remember things, we ask questions, repetition. So this is us remembering something, assigning a value to a variable. We're remembering a name-value pair. All right, questions, comments, concerns, bribes. All right, good luck at Mad Hacks. Who all's going to Mad Hack?
Raise your hand. She said yes.
What? You said yes now?
Say no.
Are you raising your hand?
I'm asking a question right now.
Well, but my class is still going as long as my recording is still going. Who all's going to Mad Hacks? Have you committed to going or not?
Just drop it.
Yes.
Because I'm going to be really mad if we just gave you the lecture last class about committing to things, and then you said, no, I'm not going, and then you said, yes, I am going, and then you say, no, I'm not going again.
No, I'll go.
That kind of thing results in
Okay.
bodily harm, I think.
So then like what remember
Clean.
doing something.
Get her! All right. I'll see everybody on Monday.
Anyway, so remember.